Hey everybody, hope y'all are doing well. Today we're going to continue our week on some statistics. Today, in the past class periods, we covered frequencies and crosstabs. Today we're going to cover correlations, like it says there on the screen. So for today, what I'm going to do is I'm going to go over some basics, just an overview of what are correlations, just describe what they are and their purpose and why we use them. And then I'm also going to show you how to actually run and interpret some correlations at the end of the class period. So stay tuned for that. You can always skip forward. And there is also another walkthrough video of correlations um, on the Moodle page. So it's another video that I pulled in, and you can look at that at any time. So correlations in research. What is a correlation? So a correlation, again, statistical analysis. A correlation reflects the strength and direction of the relationship between two or more variables. So the things we're going to be talking about today. So we're going to see how are things related, right? Whether it's positive, whether it's negative, and how strong that relationship is. So we're going to talk all about that. The things you're going to hear about are correlation coefficients, the direction of a correlation. What a perfect positive correlation versus a perfect negative correlation looks like, the direction, whether that's positive or negative. And then really thinking about what is correlational research. So thinking about this more specifically, a correlational research design investigates the relationships between variables without the researcher controlling or manipulating any of them. So for example, in the data set that you'll use in this organizational data that employees took this survey, we're going to look at how did people respond similarly to two different survey items. So did people who responded this way to this one respond in a similar way to another item, or did people respond to this way in a certain item respond inversely in kind of the opposite way to other items? Those are the things we can look at with correlations. It can be very, very useful. And I want to place another important note that correlation here does not imply causation. So a relationship between two or more variables here does not mean that one causes the other. They are correlated, but they do not necessarily cause the other, right? Let me give you an example of that. So have you ever heard of the correlation between ice cream intake and crime? If you statistically look at most cities, look at crime and ice cream consumption in U.S. population, for example, there's a very, very strong correlation between the two. The more people are eating ice cream, the more crime is happening. Why might you think that's the case? If we run that analysis, are we saying then definitively that, well, people who eat ice cream are also committing crimes? No, they're correlated, but they are not causated. They're not causal relationships. Because the other thing, a factor that maybe we left out of that analysis would be weather. Warmer weather, people are out more. People are more active, committing more crimes in warmer weather, but also eating more ice cream in warmer weather. So that's just a really famous example that we can't just assume causation in our correlations. So keep that in the back of your mind or in the front of your mind as we go through these. So why are correlations helpful? So they're helpful in various contexts. So they're helpful in academic research, and they're helpful in things like market research and organizations. So in academic research, correlational research here often provides insights into really complex real-world relationships. And what these correlations allow researchers to do is to explore patterns and trends, develop theories about potential connections between variables, and make more informed predictions for future studies. So, for example, you could be investigating whether the number of children people have is associated with their political party preference, for example, and look at what does that mean for maybe even the future of the demographics of our country. In organizations and market research, correlations can help us to identify relationships between really key variables like customer behavior and sales trends. It can provide a foundation for rapid hypothesis testing before even further deeper analysis like regressions and ANOVAs, which we'll talk about later. And what correlations also do is they aid in decision making by prioritizing variables for further exploration. So if we know that there's some sort of correlation here between these two variables, we need to know that those are the ones that we can identify to examine further. So example in organizations and market research, maybe it's determining if there's a correlation between customer satisfaction scores and then repeat purchase rates. Likely would be. If you're more satisfied, you're likely to buy that product more. That's a simple example, but what correlations can do in each of these areas is allow further research, hypothesis testing, figure out in organizations, well, if we do this here, what could be the potential impact over here? How can we improve retention in organizations, for example? All those sorts of things. So we can look at all these things and more, right, in social science. So we may investigate the correlation between education level and income to develop various hypotheses on socioeconomic mobility, things like that. So there's so many, if you think how two things can be correlated, this is how we figure that out. They're really, really important. And so how and when to use correlational, to use correlations in research. Again, correlations do not equate to causation, but we want to make sure that we are using correlations. We want to, and there are 4 items up there. When we want to determine if an association exists between 2 or more variables. 2, investigate relationships without manipulating those variables. So it's not an experiment. We're looking at how they are currently existing, and correlations currently in data we have. 3, when we want to explore patterns or trends in historical data. So maybe it's data that folks have collected for many, many years, or data folks collected a couple of years ago, or in past months, whatever it might be. Maybe analyses that hadn't been done on them before. And then developing theories or generating hypotheses for future research. All those things we can do with the help of correlation. So again, you can look for some additional notes on here about what are the points here, the key purpose of correlational analyses, like studying variables when manipulation or control isn't possible or ethical or needed, helping us to identify relationships that do warrant that further investigation. Maybe when 2 variables rise or fall together, or maybe move in opposite directions. Backward-looking nature of correlational research is also, I think, good to point out here. So correlations are often based on existing or historical data, meaning that they provide a snapshot of past relationships. For example, maybe examining historical weather patterns to see if there's a correlation between rainfall and crop yields and those sorts of things. When to use correlations. Again, it's when you want to explore relationships in real world uncontrolled settings for hypothesis generation and all those sorts of things that we've mentioned. They're really, really useful. Some limitations of correlations, though. I want to point this out as well. So correlation, like I mentioned twice now before, does not imply causation. Always consider potential confounding variables or external or third-party variables and those external factors in your analysis and when you're describing them. For example, I mentioned ice cream and crime. There's also, you can do the same thing with ice cream sales and shark attacks. It doesn't mean that those two are directly caused by one another, but it's confounded by the fact that it's summer. It's a summer season, that there's warmer weather, people are more active, that sort of thing. So again, some couple practical applications that I want to mention too. Again, in academic research, testing theories about variable associations before conducting experiments can be impactful. An applied field, so identifying trends in fields like public health or sociology, marketing, psychology, education, all of these things we can use correlations quite effectively. Now let's talk about correlation coefficients. So a correlation, what is a correlation coefficient? So a correlation coefficient is a numerical value that measures the strength and direction of the relationship between 2 variables. Those are the things I want you to concern yourself with most: strength and direction. Okay, that'll make sense more in just a second. So correlation coefficients always fall between 2 numbers. They fall between -1 and +1. -1 indicates a perfect negative correlation. +1 indicates a perfect positive correlation. Rarely you will ever see those variables. Now, for example, if you did a correlation between 2 variables that had the exact same data responses, you're going to get those perfect correlations. You're never going to find that. But that's what indicates, that's essentially the spectrum there. And so interpreting these values here. +1, again, like I mentioned, that perfect positive correlation. That means that both variables increase together or decrease together. So let's say if you say, I feel like I belong at my company, that's one variable that you can respond to, and another variable could be bias or discrimination is not tolerated in my company. Maybe those 2 things correlate really well with each other. So the more people respond to one positively, the more people respond to the other positively as well. when there's less bias or discrimination in an organization, there's more people feeling like they belong. That would be a positive correlation. In the same way, if they both reduce in the same way, right? So more people say that there's more bias or discrimination, there's less senses of belonging. Those things are correlated. Now, a perfect negative correlation is when one variable increases while the other decreases. So you respond more to one, less to the other. One increases, one decreases. What could that be? Let's stick with I feel like I belong at my company as one variable. That could be one potential example. Just 1 second here. Sorry, just had to take a quick pause. So again, a negative correlation is when one variable increases while the other decreases. So let's say you ask folks the degrees of harassment, how many cases of harassment in an organization, and then whether they feel like they belong. When there's more degrees of harassment in an organization, less people are going to feel like they belong. One variable is going up, one is going down. That's a negative correlation, okay? So that positive correlation where they both increase together, that would be indicated by a +1, so a positive correlation. That negative correlation, one increases, one decreases, that's a negative correlation by a negative number. So a perfect negative correlation would be -1. A zero, an item that includes 0, would be no correlation at all. So there is no linear relationship between those variables. So values closer to +1 or -1 indicate stronger correlations, while values closer to 0 indicate weaker correlations. Pearson's R, you see Pearson's R on the screen. So Pearson's R, or you can call it Pearson correlation coefficient, is the most widely used measure for these linear correlational relationships. And what the Pearson R does is it assumes that the data is continuous and normally distributed. For example, Pearson's R of 0.75, it would indicate a strong positive linear relationship, while 0.3 would indicate a weak negative relationship. We'll get into what is strength, what's weak, what's moderate strength, what's strong in just a second. So when to use Pearson's R? So Pearson's R is appropriate to use when the variables are measured on interval or ratio scales, okay? So all those things that we've mentioned here throughout the class. Remember going back to those. So data should show a linear trend. So you can use scatter plots to visualize this data to verify its assumption before calculating. So Pearson's R examples of scatter plots are on actually the next slide of what shows a strong versus negative relationship as well as a positive versus negative relationship. So a couple limitations of correlation coefficients that I think it's important to mention as well, though, is that they can only measure linear relationships, right? So if the relationship is nonlinear, Pearson's R may not capture it accurately. And it's really sensitive to outliers, which can distort the correlation value. Like I mentioned, correlation is not causation. There are these external factors that can be included. But these are really good tools to assess whether these two variables are correlated or not, two or more variables. So here are examples of scatter plots. So I wanted to show first, let's start with positive and negative relationships. So let's first start with a positive relationship. This on the upper left here is an example of a positive relationship. It's going up, right? That's the easiest way to describe it. It's going up like that. It's a perfectly linear positive relationship. You're likely not going to see that strength of relationship. A 0.42, that might be a little more common. But you see how it's still, that data is still linear. You could still draw a line through it and have a good example about what this data is pretty much showing you. So this is a moderate to weak relationship, but is still a positive relationship there. Let's look at the same way, negative relationship on a scatter plot. This is a perfect linear negative relationship, that -1. Again, you're not going to see that typically, but -0.4, that's going to be more likely to see. But you can see the direction of that data still is around this sort of linear, this line, this direction. So here again, on the top, that's what a positive relationship looks like in terms of data, scatter points, plot points. On the bottom is what that negative relationship looks like. Let me clear that quickly. Now, just to mention one more, and I actually want to show scatter plots just one more time here, but that's, again, example of positive and negative relationships. Let's also look at variance and covariance. So I mentioned variance is how we measure the spread between a data set. We'll talk a little bit more than that later, but what I'm really concerned about is just that you understand what that is. So that's just a measurement of how spread out the numbers in a data set are. And then covariance is another component here, where covariance is it measures how two variables may vary together. So uses the mean of each variable as a reference point really for it. Positive covariance, again, is that variables tend to move in the same direction. Negative covariance is that variables tend to move in the opposite direction. It's useful just understanding the distribution of a data set. So a small variance means that the data points are close to the mean, while a large variance indicates that the data points are really more spread out. So let's say your mean score is 4.5. And a small variance would mean that most of the data points are around that 4.5 measure. Let's say you had a large covariance, though. Maybe you have a lot of 2s and a lot of 6s or whatever that might be that has spread out the data a ton, because you can have the same mean score with two variables that are close to each other and variables that are very far away from each other, but you can still list the same mean score. So that's what variance is looking at. And then covariance, while variance focuses on a specific spread of a single variable, covariance looks at, again, that relationship between two variables. So it's not just normalized, so it doesn't give the strength of the relationship, just the direction, positive or negative. The difference is here between variance and covariance, okay? And again, you won't necessarily have to applicably use this, but it's really good to know. Variance is about one variable. Covariance is about the relationship between two variables. Covariance can help identify patterns or trends, but needs to be paired with correlation to standardize the relationship strength, okay? So when we're talking about strength of relationship, these are the sorts of things that we're talking about, whether it is a really strong relationship or not. We're going to get to form, direction, and magnitude or strength on actually the next slide. So we'll get into that more. And if you're more confused, again, feel free to ask me questions about this, and there is more in the notes section of this slide. But let's talk about form, direction, and magnitude. So form refers to the shape of the relationship in a scatter plot, essentially just the shape of the relationship of the correlation. So a linear form points to a straight line pattern, right? We mentioned that. So if you look at the next slide, that upper left would be very linear. Curvilinear would be a curved pattern. So stress level and performance would be an example of what that sort of could be. So look on the left-hand side there. And then no relationship is that the points are scattered randomly with no discernible patterns. That would be, on the upper right. There's no real discernible pattern there. Direction now, and I really want you to focus on magnitude and direction. These are the two I really want you to hone in on. So direction indicates whether the variables change together in the same way or change in opposite ways. So positive, like I mentioned, as one variable increases, the other increases. So study time and grades, for example. Negative, as a negative direction, as one variable increases, the other decreases. So whether that could be something like greater exercise time for an individual, the less body fat that person likely has, as an example. Magnitude now, this is the new part. Magnitude refers to the strength and consistency of the relationship between variables, the strength and consistency. So higher numbers here in terms of magnitude mean greater strength of the relationship. That is a stronger relationship. So correlation coefficients like that Pearson's R range between 0.1 and 1, like we mentioned, and the interpretation of those values. So I will in the notes here for these slides, I actually explicitly state what determines a weak relationship, what determines a moderate relationship, and what determines a strong relationship. So around that 0.1 to 0.2 is going to be more of a weak relationship. Moderate relationships, that 0.3 to 0.5, and then strong relationships are going to be 0.5 and above typically. So that's how you're going to assess whether those relationships are strong or not by those numbers that they give you. And again, I'll tell you exactly how to actually determine whether that's strong or not. So for example, a 0.7, so if we go here, 0.42, that's a moderate strength relationship, that middle or that bottom left or that upper middle one. That 0.42 or 0.4, that's a moderate relationship. Now, if that was a 0.7 or a 0.8, that's a stronger relationship. So that's how we refer to those. That's how we figure out what actually are a weak or moderate relationship in that. And so in determining significance as well, I'll talk about that in just a second because that's going to be important. There are key steps that you need to take for correlations, okay? There are these key steps that you're going to need to do, especially for the assignment. You're going to first obviously run the analysis, and then you're going to test significance, and then you're going to test direction, and then you're going to test magnitude. Those are the three things that I need from you. So determining significance is when it's less than 0.1, less than 0.5, or less than 0.01. So statistical significance, really what I want you to look for is anything 0.05 or less. It's going to make sense in a second when I actually show you in SPSS how to do that. So let me get back to that. But then I also want to talk about the difference between a two-tailed versus a one-tailed correlation confidence test, because we're going to be conducting two-tailed correlation confidence tests. All I want you to know about this, there's more detailed explanations in the notes under the slides that you can reference for this day. But when we get into SPSS, you're going to see that we're going to select a two-tailed test. And here's why. There's two key differences. There's direction and significance level. Focus on, I really would just ingrain the direction of the test. A two-tailed test, which we're going to use, looks for any relationship, whether that's positive or negative. And then a one-tailed test looks for a specific direction. So you're testing whether it's for a positive or negative direction. We're going to use the two-tailed direction, okay? So we're going to look in at this, and I'm actually going to share my screen in SPSS. I'm going to show you how to do each of these. Again, remember, for your assignment, I want you to look at statistical significance, the direction of that relationship, and the strength of the relationship as well. So let's get into that. There is a video here that you can watch that I've included in the slides. That's also included in Moodle, I believe, as well. So feel free to watch that. I'm going to skip past it just for now. And then we're going to come back to this, the introduction to your quantitative research assignment, in just a second. But now let me share my full screen, and I'm going to pop up SPSS because we're going to look at some data. Everyone's favorite. All right. We're in our example data set that you're going to use for everything. Our example testing that we're going to use for your assignments as well. I'm going to show you how to run a correlation, okay? So we're going to, if you recall, we're going to look at the same way we ran the descriptives. We're going to go to analyze in the top part of the screen. That analyze is key. Now, instead of going down to descriptives, we're going to go down a little bit further, and we're going to go to correlate, okay? Now, I want you to run a bivariate correlation between two variables. That's what I want you to look at. That's what I want you to know how to run. So we're going to go to correlate, and we're going to go to the second bivariate, not with confidence intervals. We'll get to how to add confidence intervals here. So we're going to go click on bivariate. I'm going to remove those two just so you can see the whole process. And I want to show you what a I want to show you what a statistically significant relationship looks like first. Okay. So I'm going to look at, let's see, bias or discrimination is not tolerated in my organization, and then I feel like I belong at my company. Those are the two areas that I'm going to look at. So what I'm trying to look at here in this correlation is, are these two variables correlated with one another? Are these two associated with one another? I want to make sure that down on the left here that Pearson is selected. Remember that Pearson's R? That's where we're going to select. Make sure that two-tailed, for the test of significant, we're doing a two-tailed test. We're testing both directions. Make sure you check flag for significant correlations because it'll actually tell you. And then in the upper right, go to confidence interval. And this probably won't be selected for you. Make sure you select estimate confidence interval of bivariate correlation parameter. And we want a confidence level of 95%. What that's going to tell us is anything less than 0.05, which will, remember I mentioned in the slides, less than 0.05 means statistically significant. It's going to tell us if it is significant or not. So let's click continue and click OK to run this thing. All right, we're here. This is what a correlation looks like. So what I want to point out, let me draw it, is that you see this has a perfect relationship correlated right here. And the reason for that is if you read this table, go down and then over, Bias or discrimination not tolerated. It's just being correlated with the same variable because it does a full correlation table. So ignore that where that's the perfect relationship because it's just comparing the same exact variable with itself. So ignore all of that. What I want you to look at is like right here or right here, because that is correlating with the separate variables. So let's look at how is bias or discrimination is not tolerated in my organization. How people respond to that variable. How is that correlated with I feel like I belong at my company? So we're going to look left and then down, and we're going to get to this box right here. So first, I want you to first look at this significance. That two-tailed significance right there. This is number one. That's number one. You see it's less than 0.01. What does that mean? That means, and you'll see these little asterisks here under that number, under the Pearson correlation number, that means that it is statistically significant at the 0.01 level. Okay, so that's what you need to look at first. That's the first thing. Is that statistically significant? Yes, it is. This actual analysis, how you're doing this, will tell you if it is statistically significant or not. Right there, for example, the confidence intervals. It is statistically significant. That means that you should report this out, that this is an important statistically significant relationship, that these two variables are correlated with one another. So what's the next step? Step number 2 is to look here at the Pearson correlation, okay? The Pearson correlation gives us the strength of the relationship. 0.8, oops, excuse me, 0.484. What does that mean? Remember we said anything less than 0.3 is a weak relationship. 0.3 to 0.5 is a moderate relationship. 0.5 and larger is a strong relationship. So what this means is that this is a moderate strength relationship, that this is a moderately strong relationship, okay? Now, we have 2 out of the 3 steps that you need to know for completing your assignment. We have, is this statistically significant or not? Yes, it is. Check box 1. 2, what is the strength of this relationship? Well, it's a moderate strength. 3, is it positive or negative direction? Is this a positive or negative number? That is a positive number. So that is a positive relationship. If this was a negative number, let's say it had a little negative sign in front, that would be a negative relationship. So, we get a different color. It is a positive relationship. So how will you describe this? Is we would say, well, I feel like I belong at my company and bias or discrimination is not tolerated in my workplace. This is a statistically significant, positive, moderately strong relationship between these two variables. So these are how you interpret correlations, okay? So yes, it's statistically significant. That means we're going to report out the rest of this. Let's say if I ran this and it wasn't statistically significant, all you would report out then would be these two variables are not statistically significantly correlated. That's all you need to report out. But because these two are, there's more information we need to describe. So 1, yes, it's statistically significant. 2, it's a moderately strong relationship because it's in between 0.3 and 0.5. And then finally, it's a positive relationship because it's that positive number. What does that mean again, positive? It means the relationship is like that. It's increasing. As both variables increase, as one variable increases, the other also increases. And so it's a moderately strong relationship there. So let's get rid of all that. Let's run another, okay? Let's run, I'm going to show you what a non-statistically significant relationship looks like. So let's correlate again, bivariate. Let's take these two out. Keep all the same settings, but let's do, at work, I often interact with coworkers who are different than me as one. Leaders at my organization explicitly acknowledge diversity amongst people. We're going to keep the same confidence intervals, 95%. Let's run it. So here it looks a little different, doesn't it? So here, let me get that pen out again. See that significance? 0.66? That's not less than 0.05, is it? And down here, you can see it again, 0.66. And there is no, like up here in the original, let me scroll up. In the original, excuse me, sorry, let me scroll up. There we go. In the original, we had this that said correlation is significant at the 0.01 level. Okay. In the down below, what don't you have? You don't have that. That's not included there. So it'll tell you whether it's statistically significant or not. You don't have to compute that separately. It's going to tell you if it's significant at the 0.05 level, 0.01 level. So let's say for your assignment, you're going to have to find some statistically significant variables that you're going to test. But let's say if you can include one that isn't, if that's what you find. Here, all you would have to describe this as is these two variables. At work, I often interact with coworkers who are different than me, and leaders at my organization explicitly acknowledge diversity amongst people. These two variables are not statistically significantly correlated. That's all you'd have to report out. But for the top one again, remember you would say these two variables, bias or discrimination is not tolerated in my organization, and I feel like I belong at my company. These two variables are statistically significantly correlated. And then you include at the 0.01 level. Then you'd say, hey, it's actually a moderately strong relationship. The strength is moderate. And then 2, it is a positive correlation relationship. That's how you describe correlations. And what it means is that's a moderately strong relationship between these two variables. That as people say that bias or discrimination is not tolerated in their organization, more people also feel like they belong at their company. That's what this finding is telling us. That's what we're finding through the data, okay? So that's why correlations are important, and that's how you describe, and that's exactly what you're going to do for your assignment. So you can look back at the frequencies and cross tabulations walkthrough the same exact way. You can describe that here. This is how you describe correlations. And again, refer to the walkthrough video on the Moodle page as well. But this is what you will do for your assignment and how you describe that, okay? Let me go back for a second. Let me just share here. The introduction to your quantitative research assignment. So this is the last thing I have for the day, but I want to walk through it quickly. So let's go to Moodle. Make sure we're logged in. Let's go to our course page. So you can see that for this date, here we go. So introduction, so correlations here. Again, here's a reference of how you can run correlations. There's another video up there that you can look in. Your data set is right there. You can see that you have a quantitative research assignment due on the 28th. You can submit right there, and I'll tell you exactly how to do that. We talked about last class period, that last video. I showed you how to export an output from Qualtrics. You'll use that method to submit. So let's go to at the bottom of the page, at the bottom of the Moodle page, where is it? Your quantitative research assignment worth 50 points. So you have to include tables of analyses in your report. So you can copy and paste, screenshot, or add the data that you designed. So you're going to run the different analyses that we've already talked about. So you're going to run a frequency analysis. You're going to run 3 of them. So performing 3 frequency analyses on non-demographic survey data. So remember, we already did the walkthrough and the practices of running frequency analyses. You're going to do 3 of those at least. And then you're going to explain to me. You're going to interpret. You're going to include the tables of the data, and then you're going to include a few sentences explaining what does each description mean. So I ran this on this data. What does it mean? If there was a mean score of 0.2 for I feel like I belong at my company, you'd say not a lot of people at this organization feel like they belong at this company. So what should me maybe as the example leader in the organization know about the data? You're going to run 2 cross tabulations as well, each involving a different demographic variable. So that could be gender, disability status, generation, sexuality. It could be any of those variables. So please include the tables in the analyses of your report and then interpret that. So what are the different responses for each demographic item reveal about the organization, reveal about what you're finding? 3, you're going to also run a correlational analysis. You're going to run just one correlational analysis between 2 variables of your choice. So include the table and then discuss What is the direction? Is it positive, negative, or none? What is the strength of the relationship? Remember, anything less than 0.3 is weak. 0.3 to 0.5 is moderate, and then 0.5 and above is strong. The level of significance. Is it significant 0.05, 0.01, 0.10? Again, it will tell you that in SPSS, and then the implications for the organization. And then finally, kind of the fun parts here, I want you to provide, once you have all this data that you ran for this example organization, give me one actionable recommendation that you have for the organizational leader. I'm not going to be a stickler on points in this specific section. What I care about here is just how can you look at that data and then say, what can you do with it? That's all I care about. So be creative there. That's all. If you give a good faith effort there, that's all you need to do. And then future research steps. So suggest one or two next steps for further research that could provide additional valuable insights for the organization. Again, good faith effort. Be creative there. What do you think? That's all that I need on there. So include the tables, write in a clear and professional format. Let me know if you want to go over this assignment one-on-one. Happy to do that. We can go over it, but take a look. And let me know of any questions that you do have. Refer back to the slides. So all this sort of stuff, like right here in the correlational analysis, for example, all of that information you need to interpret that is in today's recording and in the notes, in the detailed notes under the slides that I'm posting to the Moodle page. So you don't have to stress too much. You don't have to memorize stuff. You can reference these materials as you're going through the assignment. So please let me know of any questions that you all have about the assignment. The slides and everything from today will be posted. You can look to the Moodle page for the walkthrough videos of how to run frequencies and crosstabs, how to run correlations, and how to interpret them. So you can look through all those things, and we can always meet one-on-one as well. And we'll practice on Friday's class as well as all of us together. Okay, everybody. Thanks very much for your time today. I greatly appreciate it, and I will see you next time.